So even today for our discussion, we are going to continue with zone-based firewall and CBAC. This is another example. These two are another examples for stateful firewall. Stateful firewall. Previous class we saw the other stateful example, which is reflexive. Right. So to do that, let me take the same topology which we were using for reflexive ACL. We can make use of the same topology to save time. Yep, this is the same topology I'm going to use. We were doing reflexive ACL here. I'm going to remove those reflexive ACL and then put CBAC and zone-based firewall. Right. CBAC, context-based access control. Now, what is special in this? We are not we are not dependent on ACL to do the inspection. We are not dependent on the ACL to permit or deny. We do something advanced level, meaning this can work in higher level layers like application layer. When we talk about ACL, they are limited to layer 3 and layer 4, not more than that. But this CBAC can do deep packet inspection. Deep packet inspection means what? It can even see layer 7 and so on, right? So this can do layer 7 kind of inspection. It can do deep packet inspection, not just limiting yourself to layer 3 and 4. You can do even deep packet inspection. All right, that's the beauty of CBAC. That's the reason why we don't use reflexive ACL much. You might have not even heard about reflexive ACL before our class. So the reason is we have something better than that. Even better than CBAC, we have something called zone-based firewall. But CBAC is also in use in the real world. I have seen in many places CBAC and zone-based firewall both are used together. Sometimes I have seen only CBAC. It depends. But reflexive ACL is not much popular. The reason is there's a better way than reflexive ACL, which we have something like this CBAC. Right. So in our example, this is example topology. Not exactly the same topology. We are going to have an example topology, and also I'll show you example configuration. Now the frame relay cloud, it can be any cloud. It need not to be always frame relay cloud. What I mean is traffic from untrusted network. This is an untrusted network, the cloud. The traffic from untrusted network, we don't allow to get inside our network. So there's a firewall. There's a wall blocking all the traffic coming from outside. So what you can do for this is you can write an ACL and block all the traffic here. Write ACL as we did for reflexive ACL before and block all the traffic here. And then we'll write a policy saying inspect the TCP packet that is going from inside to outside. Inside to outside, that's very important. So if any traffic is going from inside and if it is a TCP packet, then the return traffic will be allowed. Will the ping happen? The ping will not happen. Why? You did not inspect ICMP. We inspect only TCP. So depending on your need, you can say what to inspect and what not to inspect. Whatever is inspected, only for those the return traffic will be allowed to come back. Others will not be able to. So that's the basic idea behind CBAC. Even reflexive does the same thing, but you write an ACL to do it. Here you are using a layer 7 concept called inspect. Yep, instead of ACL you say inspect. ACL cannot work beyond layer 4. This can work till layer 7. You can also match with a website. You can also match with a particular word inside the data, and if that word is matched, you can take some action. So such a nice that's why we call it as deep packet inspection. CBAC can do deep packet inspection. Alright, so here is an example. Now what I do is, first I block all the traffic. This is optional. I block traffic coming from anywhere going to anywhere. I am blocking it by using an extended ACL. Where do I call the ACL? I call the ACL on the serial interface. This is my router, this is the serial interface, outside interface, and I'm calling this ACL here inside. So when a traffic is coming in, it will check with the block ACL. What does block ACL says? Deny any packet. IP means it's every protocol. Deny IP means deny TCP, deny UDP, deny everything. So I'm blocking everything now coming from outside. But in our case, you remember yesterday we were running OSPF. So we may be allowing only OSPF. When I say allow OSPF, implicit deny will be there and it will deny all the traffic. Next is, we go under this inside, don't go under the inside interface. Next what we do is, we write the inspection commands. This is what CBAC commands. IP inspect name, give any name. Sambat, I'll give Sambat TCP. Meaning what I'm saying is any TCP packet going? If it is going, remember it, or make a note inside the diary called Sambat. You can, this is, here I am using a word called remember. So write it inside the remember diary. Means it is like a stateful table. I'm asking to make a statefulness. So any UDP traffic going, then it will remember who is going to whom. Say for example, if A from inside is going to B here, if it is a TCP packet, say for example A is telnetting. If it is a TCP packet, then it will remember. It will make a note. And then when B responds back, it will open the door for B to come in. And you know very well that in this statement what we did is, we have denied all the traffic. But because inspection is done, only the traffic will be allowed. ACL may say I will not allow it, but CBAC has got more power than ACL. It works beyond ACL, so it can override the ACL rule. So any traffic going from inside to outside, the reverse traffic will be allowed if it is matching with TCP. Similarly for UDP, if you want the ping to happen, then you use ICMP. Okay, if someone is pinging from outside, no ping will happen. Why? Because on the serial interface you are saying out as a policy. IP inspect, you are calling this name. It depends on how you call it. When you call and say out, then traffic going out will be inspected, so that return traffic will be permitted. Of course, I do agree, but in reflex ACL, you are using access list, and access list cannot go beyond layer 4. Now I can do more granular. Here I am just showing what easy examples like TCP, UDP, ICMP. You can go HTTP, HTTPS, more granular, which is layer 7 properties. Correct. No. And not only that, ACL, you need to write. It's a more manual work. This is just one inspect command. IP inspect. Simple. This is more simpler than ACL, but more powerful as well. All right. So this is more effective because it works from application layer onwards than this one, reflexive. Alright, so to verify, these are the commands we will use: show IP inspect, and then the interface name we will type, or show IP inspect session. Make a note of these two commands. Make a note now. Alright, so before we go into zone based firewall, let us finish the configuration of CBAC. So it's the same old topology which we were using yesterday. All that I'm going to do is I'm going to remove the ACL, show IP access list. Good, no access list, which means that I need to ping from here to there. Ping source. It's happening. Similarly, I'll also try pinging from. It's happening. So there is no ACL. Even the traffic is going from outside to inside now. R3 is like outside for us, R1 is inside, R2 is our firewall. So what we are trying to do is CBAC. Now CBAC, as we discussed, first of all the firewall will block all traffic coming from outside to inside. To do that, we'll write an ACL, access, any ACL, numbered or named. Let me use a numbered access list. 101 deny IP any. I have denied. Sorry, let's do one thing. Yeah, we permit OSPF so that all other will be denied. So I cancelled 101. Again, I'm writing another new 101, permitting OSPF from any to any. Done. What is next is I'm going to go to the interface which is facing outside. This is F1/1 and say IP access group 101 inbound policy. According to my inbound policy, I should not allow anyone coming inside, correct? Except OSPF. So if that is the case, now I should not be able to ping. The ping is not happening. Yes, let me also check it from here. Previously it was pinging, now it is unroutable. Okay, so none of the traffic from outside, even telnet, let us enable telnet on both the side. Line VTY 024, password 123. To show history, I'll copy this and paste it on R3. Right, so even the telnet will not happen from R1. You see here, now I'm going to say telnet 3.3.3.3. it's not happening. So no traffic is going through the firewall. Similarly from outside also, when I say telnet 1.1.1, not happening because of the firewall. Right, now what is our case, or what is our objective? Any traffic, if it is a TCP traffic going from inside to outside, should be permitted back. The reply should be permitted. So what I can do is I can simply go and write an inspection. Instead of writing an ACL, I am writing IP inspect name, give a name. I'll say my underscore policy, any name, my underscore policy. I want to say TCP telnet also. I think I can specifically say telnet. See, only telnet. You know, wonderful thing, you know, CBAC. You see, hundreds of protocols you can match. This is not possible through ACL. I'll show you. See, hundreds of matching you can have. Voice related, video related, everything in the world can be matched. IMAP, IMAP3, Wonderful. Hundreds of protocols. BitTorrents, you see. I do not want anyone to use BitTorrents. Very simple. But it is very difficult where in writing an ACL. Apple. You know about Apple. I use Apple everywhere. But I also hate Apple for one reason, the bandwidth consumption. But the service is very good, so I love Apple always. Anyhow, now I say here, now telnet, I already said telnet. So only telnet traffic is inspected. Right now no other inspection happens. So only thing as of now I said is, come on, where is that inspect telnet. Only this much I have said. So ping will not happen, SSH will not happen, anything other than telnet is not going to be inspected. Now just writing this is not enough. You need to go to the firewall which is blocking 1/1. 1/1 is blocking everything. I am saying, yeah, you are blocking, but consider this inspection. IP inspect my underscore POL in or out? In. Previously, no, sorry. This is inspecting out, okay? Out. Yeah. So, if this is going out, then you should permit. Which is going out? Telnet is going out. If telnet is going out, you need to permit inside. So, interface level we have said. Now, if you see, from R1, when I do telnet, it happens. 1, 2, 3. I'm in. Let us go and verify this on R2. What are the commands that you copied? Show, IP, inspect, interfaces. See, it shows that on interface F1/1, there is a rule called myPol, and what it is doing, it is working on outbound policy, and it is only auditing the telnet. Let's do one more thing. Show IP inspect. Wonderful command. This is very important command. See, beautiful. It says, yeah, traffic was going from this one, and this is the session ID. Look at this. The session layer is coming into picture here. This is the session ID of it. So, no other session will be allowed actually. Only this session will be allowed. And this is the source port number, because it was going from 10.0, it's a random port number. And it is going to 3.3.3.3 because it's a telnet. Destination port number is 23. And the telnet session is kept open for the reply packet, the response packet. Session is open. Now, it happens from here to here. I finished, I disconnected the telnet. Let's see the status now. Same command, inspect session, gone immediately. Now, let's go to R3 and try telnetting. Will not happen. Now, let us try telnetting when the session is there. Session now will be there on R2. Yeah. So on R2 session will be there. Now will I be able to telnet from R3 now? Not allowed. Why? Session ID will not match. Source will not match. Here the source is like 3333 or 20.0.0.2. So outside to inside, not at all possible. Anything going from inside to outside, it is possible. Will the telnet happen from R1? Sorry, ping happen from R1? No, because we have not inspected. So let us allow the telnet to happen. One small command. What is that? IP inspect name my underscore policy ICMP. Now if you go to R1, the ping happens. Let's see the session ID. You see, for ICMP. The session IDs you will see, and you can do more granular match. Yes, I showed you a lot of protocol, right? I showed you only under TCP. There are UDP protocols, there are IP, there are a lot of things that you can match with. You can also match a regular expression, in CBAC. So next is zone-based firewall. Zone-based firewall, it's a long process. It's not that simple like CBAC, but it is more powerful. Okay. So before we get into zone-based, let us remove all those configurations that I did. I'll remove IP inspect mypol, and then I'll also check do show run interface f1/1. I'll cancel all this access list. No access list 101. Alright, there is no restriction now. Show IP access list, no access list, show IP inspect interfaces. There is no inspection on interface. Next is zone-based firewall. Let's get into it. Zone-based firewall. So this is also another example for stateful firewall. Right, another example for stateful firewall. The main difference between zone-based firewall and CBAC is this. Zone-based firewall by default will block all the traffic passing through the firewall, whereas CBAC will allow all the traffic passing through the firewall. Main difference. Let me show you the difference between CBAC and zone-based first. First difference. Where did you configure inspect command? Where did you apply the inspect command? Under the interface, correct? Here we will not apply any policy under the interface. We'll apply it on zones. So a zone may have more than one interface. So we will apply the policies to the zone. This controls inbound and outbound access on the interface, whereas this controls the inbound and outbound between the zones, not between the interface. So this is another very important difference between CBAC and zone-based. CBAC interface centric, zone-based zone centric. Here you know very well that all traffics, okay, here last point, it permits all the traffics. By default CBAC permits all the traffic. So to avoid that, what you did is you wrote ACL to block all the traffic coming in except OSPF. Correct? We don't need any other any sort of configuration like that here. The reason is all traffics are by default denied. Now if you want to allow some traffic in, if you don't write an ACL, see, if you would have not written an ACL on the CBAC, you would have not done that lab in first place, because by default all traffics are allowed. So you are blocking everything because you want a firewall. You blocked everything, and then you said inspect for all the traffic that you want the response to come, the reply to come. Now, how did you wrote CBAC? By using an IP inspect command in the global configuration mode. Or you can also use ACL, but no, don't go to ACL. Then again you will have one more doubt. What is the difference between using an ACL and CBAC? So better use the inspect command. Inspect command itself will do a lot of things. Now when do you want ACL? If you also want to match with some IP address along with the inspect statement, then you need ACL. Now in in zone-based firewall, we'll have class map, policy map. Means, we'll use modular approach, MPF, modular policy framework. We'll write some class map. In class map, we'll say what traffic to get inspected. In the policy map, we'll say if a match is happening in a class map, what action to be taken. In our case, we want to inspect it. So there are three options: inspect, pass, drop in the policy map. So modular approach we will use. We will not use the inspect command under the global mode or the ACL. Instead, you will use a class map. Now this supports even layer 7 inspection. CBAC supports it, but not to the zone-based extent. In CBAC also we saw that it supports a lot of layer 7, but not to a extent of what zone-based can do. So here it is written as not supported. Fine, but CBAC can also do to an extent. Next is CBAC is supported almost on all Cisco IOS. So 11.2 and all, very old one. Even from that 1990s router, it supports, CBAC is supported. And zone-based firewall is supported from 12.4 60 onwards. If you go back 12 years from now, those routers they don't support, because this came around 10 years back, 12.4. Right, as we already know, CBAC is permit all, zone-based is deny all. Alright, so as I already told you, we use MPF approach or MQC, modular quality of service class, MQC, which is also used in QoS. The same concept we use here for the traffic to get matched. I'm talking about this point. Alright, we don't use inspect statements under the global mode. Instead, we use class map and policy map. Basically, what we are going to do is we are going to divide our network into different zones. If this is your router and this is your inside and this is the outside, I'll make F1/1 as outside zone and this one is inside zone, F1/0. No traffic from a zone can penetrate and go inside the other zone unless you permit. That's why we saw here the last point, all denied. So we put the interface under different zones. So you may have more than one interface also, never mind. So we put interface in different zones. No traffic between zones are permitted. All are denied. So unless we write a policy explicitly and allow it, it will not be allowed. So the last point that we learned is true. So these are the steps that you need to remember. Before going to the steps, I would like to say something very important. Traffic in same zone will be forwarded by default. Very important. See, you have a two interface on the outside. There's a router. This is inside. Two interface or three interface. All these are in same zone. So traffic from this interface can go through. You no need to permit it. Traffic in same zone will be forwarded by default. This is a very important point I want you to remember, The reason is ASA will not allow this. ASA will not allow this, but zone-based firewall will allow. Now, if you write a policy for a traffic from inside zone to go to outside zone, session will be maintained for 30 seconds. You telneted from inside to outside. The reply packet traffic will be allowed for 30 seconds. Within the 30 seconds, if it is not coming, session will be removed. Session will not be there. Session will be removed. Alright. So these are the very important thing. Let us get into the steps. First step, define zones, meaning create zones. How do you create zone? I'll show you. See, here in our diagram I want 3 zones. One is called DMZ, another one is called inside internet, another one is called private. So create zones. For first step, this is the command to create zone. This is the first step, create zone. So in our diagram we saw 3 zones, internet, private and DMZ. This diagram is not matching with this example. Alright, this is again another example only. When we configure, we'll have an exact scenario. Right, first create zones. So that is the first step, define the zones. Next is, if you have some policy saying any traffic going from public zone or any traffic going from private zone to public zone, I want the return traffic. So if that is the policy, then first you need to pair the zones, group the zone between which you have policy. See, you may have one policy between these two, you may have another policy between these two, you may have another policy between these two. So any policy that you have between private and internet, you can apply only to a zone pair. So you need to first of all pair these two with a name. In our example here, you see, zone pair security, give any name. Actually I'm pairing these two zones, so you can give any name. I'm saying private - public. That's the name for the zone pair. Source, from where the traffic is going. From private it is going to where it is going, to the destination public it is going. If it is going, then it's a pair. So that is the second step. Second step is what? Creating a zone pair and also mentioning the direction from where the traffic to where it is going. From source, private zone to public zone, not from public zone to private zone. This is very important. What is source and what is destination is very important. If source is private and destination is public, then we are a pair, and that pair is identified with a name called priv-pub. It can be any name. So that is the second step. So what we have seen, defining a zone and then pairing the zone. Next is, we have some traffic to match. Say for example, telnet should be allowed. Where do you specify that? Under a class map, like this. Class map this one, class map type inspect, and then private to public, policy map, top, okay. Class map. So class map type inspect, match all. Match all means what? This is what default is. You may have many match statement. Match, protocol, telnet. So what it means, match all means the traffic should match with the ACL. ACL says what? It should be an IP traffic going from this to anywhere. So match all means this should match. Also it should be a telnet traffic. If anyone is matching, then it is not going to, this class map will not be effective. Now in our case we have only one match statement. Why we have this match all then? I tell you, this is default. Even if you don't mention, it is match all. If you want to match any one of the statement, you need to say match any. Okay, so we have said class map, type inspect, match all, match, this is optional. And then you give a name. You call the access list to say what traffic you want to inspect. And then you can also say protocol. Okay, you need not to write an ACL. This is just an example for zone based firewall. And then you go to a policy map and call the class map. This is a class map. Call the class map and take the action. What action you want to take? Inspect. Here what, according to this example, telnet, ICMP, everything is allowed because you use word IP. Now this policy map has to be called under the zone pair. So go inside the zone pair and say service policy type inspect, call the name, the policy map name. That's all. So see, we have not applied the zone pair, or we have not applied our policy map under the interface. Now you created two zones, right? But where are the zone members? See, this is F1/1, this is F1/0/1. So this is zone member inside or private. This is zone member public. So that is what we are doing here. Go under the interface that is facing the WAN and say public. The zone security name by using the command zone member. Go under the inside interface. Inside interface can be a physical interface like this, or it can be a SVI, logical interface, and call the, make it as a member. That's all. See, steps. We created zone and we paired the zone. We wrote a class map. We wrote the policy map, and we applied the policy map to the zone pair, and we assigned the interface to the zones. The three major action, as I told you. One is inspect, you already saw. Another one is simply pass or allow. Another one is drop. Pass and allow is not inspection, it is not stateful. Inspect is stateful. Alright, so I'm going to implement this, I'm going to demonstrate this on a router. Alright, so now we are going to first step, we are going to create the zone. So command is zone security. I'll name it as inside, okay? Can be any name. One zone. Another zone I want to create, zone security outside. So first step is over. What is the second step? Pair the zone. Command is zone-pair security. Give a name for this. I'll say in underscore out. Some name. Alright. So some name you can give. I'm saying in underscore out. Source. Tell me, what is the source? What is your policy? Anyone can go from R1 to R3, but R3 to R1 not allowed. So R1 we are planning to put inside inside zone, right? So what will be the source here? Inside zone. So this is in inside zone. This is in outside zone. Inside. What is the destination? Wonderful. Outside. Now this is what zone pair. So zone pair is created. Let us verify this too. Show zone. Show zone security. You see, you have created two zones. One is inside, another one is outside. Next is show zone pair security. So there is a zone pair security that you created with a name called in_out, and the source zone is inside, destination zone is outside, but you have not applied the policy. We have not applied. Okay, we have not applied. We will do it now. First of all, I am going to write a class map. Type inspect, match all or match any, that doesn't matter for me. I am going to simply say nothing, I'm just going to say telnet allow, can be any name, and then I'm going to say match protocol telnet. See, in our example we were seeing an ACL. Here I'm seeing only I'm showing protocol. Now class map is ready. Next, policy map, type inspect. I'll say the same thing. Need not to be the same name, but if you use the same name you will not have any confusion. And I need to what? I need to call the class. Class map name is also the same. And action that I want to take here is inspect. That's it. Now what is next? We need to bind it to a zone pair. Show zone pair, show zone hyphen, or let us go to running configuration and copy that, or do show history. Let us get inside the zone pair. This is the zone pair. Get inside the zone pair and apply the policy. Service policy, type inspect. This is the policy name, right? That's it. One last step. What? I need to apply this interface to the zones. Now show zone pair security. I can see that zone pair security has got a policy. I'm also seeing show zone security zones, but there is no interface. So let us apply the interface. Interface F1/0 zone member. Is it inside or outside? Inside. Zone member security inside. Next is interface F1/1 zone member security outside. Now after giving this, I want to go and check it. Show zone security. Look at this. Previously we were not having members. We were just having two zones. Now we got the member also. Now if I try pinging, this ping will not happen. Why? No traffic from a zone can go to another zone unless we permit it. You remember we are inspecting telnet, but are we inspecting from out to inside? No. So out to inside is not happening. R3 is outside, right? Our zone R1 to R3 will happen. Yeah, they are in same zone. That's correct. So here R3 to R1 is not happening. The reason is our zone pair source is not outside. It is the destination. So this is not happening. But when I go here and say telnet, it is happening. Let's verify. Now go to R2 and say show zone security zone security, not here. Show interface do we have any command to see? Show zone security. Okay, or one more thing, show policy map under the interface f1 slash, not on the interface, under the zone, type inspect zone pair. What is the zone pair name I gave? In underscore out. Wow, wonderful. It's a very good output. What does it say? It says that there is a zone pair called in out, and it is matching with a protocol called telnet, and inspection need to be done for the destination of 23. So far session, see, match has happened, maximum ever. Established connection, how many? 1. Before establishing it was also half open, so half open. So far 1 is matching. How long it is? For 54 seconds. Now it is 1 minute and 41 seconds. So far 1 hit has happened. Wonderful. So this is nice command to verify. The command that I was using is show policy map, type inspect zone pair and zone pair name. Are you comfortable with zone pair? So today we have seen CBAC and zone pair, which is an example for stateful firewall. In the previous class we saw reflexive ACL, which is also an example for stateful firewall. In the next class we are starting with the ASA fundamentals.